this video, we are going to solve problems involving number systems, sequences and series, graph theory, fundamentals of logic, and predicate logic, or the logic of quantified statements. So we're going to start with problem number 1. By the way, this is the coverage of the midterm examination of the logical and problem solving skills. Here, you're going to find the following. The summation from I is equal to 4 until n of x minus m raised to the power of 3. So you can see that x minus m is one group, and this group is raised to the power of 3, or cube. So we have to be very careful here. And we have to take note that for subtraction, the order is important because subtraction is not commutative. When I say not commutative, you cannot change the order. For example, 5 minus 2 is not equal to 2 minus 5, because here the answer is 3, here the answer is -3, right? So we cannot have an equal answer if we change the order. For addition, there is no problem. We can change the order and the answer will be the same. For example, 5 plus 2, this is equal to 2 plus 5. Both sides will be 7, right? So subtraction is not commutative. We have to be very careful here. And we have to start with a fourth because I is equal to 4, or that is the fourth. So we're going to exclude 1, 2, and 3. So it means we're going to start from 8 minus 8. So it is x minus m, not m minus x. So this is what I was talking about. So I is equal to 4 until n. Summation of the quantity of x minus m raised to the power of 3. When I say quantity of, it is one group. So you're going to start from 8 minus 8 raised to the power of 3 in your calculator, plus because this is sigma. It means we're going to add up all the values. Okay? Plus 0 minus 8 cube plus 3 minus 7 cube plus 8 minus 9 cube plus 3 minus 2 cube. Okay, so we cannot reverse the order. We cannot have 8 minus 0. 8 minus 8, there is no problem because the numbers are the same. But here we cannot change. We cannot have 8 minus 0. Here we have 3 minus 7, and 8 minus 9, and 3 minus 2. So in your calculator, the answer is equal to negative 576. So the answer here is A, right? So that is how to answer this question. Let's proceed to the second question. Answer is negative 576. Okay, here you're going to find the sum of all degrees. The shortcut to find the sum of all degrees is 2m, where m is the number of edges of the graph. So this is our graph containing 4 points, A, B, C, D. So using 2m, that would be 2 times 10, which is equal to 20. Now, if you're confused, try to label the edges. Okay, like this is E1, this is second edge, E2, E3. This could be our E4, E5 in any order, E6, E7, E8, E9, and E10. So we have 10 edges. This is our M. Okay, including the loop. So the answer is 20. Of course, you can do this manually by getting the degree of A, getting the degree of B, getting the degree of C, and the degree of D. All of these are 5. So the sum is 20. So, of course, if you forget the formula, you can use the manual method. We're going to look at how many times the point is intersected. For example, here A, we have 5 times. 1, 2, 3, 4, 5. B is intercepted or touched 5 times. 1, 2, 3, 4, 5. Our C, starting from the loop will touch 2 times. And this is the third, fourth, and the fifth. And D also 5 times. 1, 2, 3, 4, and 5. So if we're going to add all of these, the sum is 20. All right, so it's very simple to get the sum of all degrees. Here you're going to find the adjacency matrix. A matrix is nothing but a table. So we will have rows and columns. All right, so basically we're going to start with the first vertex or the first point from left to right. So A, B, C, and D. Okay, so how you write it from left to right should be the same from top to bottom. Okay, so you leave a space here. You have to write your A here, B, C, and D. Okay, to avoid confusion. Right, so now from A to A, we don't have any loop here. So this will be 0. Okay, because there's no loop. From A to B, we have 3. Okay, and from A to C, we don't have an edge or a line from A to C. So this will be 0. And from A to D, 2 times, because here we have multiple edges. So if we're going to add all of these, the sum is 5. Okay, so you'll be able to see the degree because we have 5 here, 1, 2, 3, 4, and 5. Now let's look at our B. From B to A, it's 3 times. Okay, and B to B is 0 because we don't have a loop. B to C is 1, and B to D is also 1. The total is 5. Let's look at our C. C to A, there is no line from C to A, so it's 0. From C to B, we have 1. And C to C, we have 1 because we have a loop. And C to D, we have 2. This will be also equal to 5 because our C to C actually will be times 2. This one. Okay? Because a loop actually has a degree of 2. Okay, so this is times 2 here actually. And D, from D to A, we have 2. D to B, we have 1. And D to C, we have 2. D to D, 0 because there's no loop. So also the answer is 5. And the sum is 20. Okay, so this is how to find the adjacency matrix of a particular graph. We just have to look at the connections between the points. Okay, so let's have number 4 now. Here you're going to find the equivalent value of this number in binary number system. So it means this is from decimal because base 10, 2 base 2 because binary. Now, as I have mentioned before, if 10 is on the left, you have to use a table. Okay, so you're going to put 59 in the middle and divide. This is remainder or RE. Okay, we divide by whatever is the number on the right. If the number on the right is 8, we have to use 8 as our divisor. So this will be 29.5 actually. We just have to write the whole number. You have to bring this one down. This is 59 minus 2 times 29 is equal to 1. And 29 divided by 2, this will be 14 point something, 14.5 exactly. Okay, so we just have to write the whole number. So 29 minus 2 times 14 is equal to 1. We always have to multiply these two numbers. And 14 by 2 is equal to 7. And here we have 14 minus 2 times 7 is equal to 0. And we continue. 7 by 2 is 3. So 7 minus 2 times 3 is equal to 1. And 3 by 2 is 1.5. So we take the whole number. 3 minus 2 times 1 equals 1, because that is 3 minus 2. Now we have to stop here because the number is smaller than the divisor, which is 2. Okay, we cannot stop here at 3 because it is still bigger. It should be smaller than the divisor. So we have to go up. Okay, so we have to start our answer with the first digit. The first digit will be the number where we stop. So the first is 1, and then 1, 1 again, 0, 1, 1, base 2. Okay, so that is our answer. Now, how do we know whether this answer is correct or not? In a few seconds, you can check whether this answer is correct or not by starting from 1 and multiply by 2. So this is 1, 2, 8 times 2, 4, times 2, 8, 16, 32. And you have to keep on going. The next is 64, 128, 256, and so on. Okay, if there are more digits. So we stop at 32 because this is the last. So if we're going to add all of this, is 32 plus 16 plus 8 plus 2 plus 1. We're not going to include this because the digit there is 0. So 4 is excluded. So 32 plus 16, 48, 56 plus 3 is equal to 59 indeed. Okay, so indeed our answer is correct. 111011 base 2 is the equivalent binary number. Okay, so that's how to do it. I hope this is clear. Now, number 5, you're asked to find the nth term of the geometric sequence. So this is geometric sequence. It means we're going to use this formula. This is the nth term of the geometric sequence. It's the nth term. We have a sub n equals a times r raised to the power of n minus 1. Okay, so we start with our a. Our a is actually 2. This is the first term, a or a sub 1. Our R is A sub 2 divided by A sub 1. Our A sub 2 is negative 8 divided by 2. That's our A sub 1 equals negative 4. So using the formula, we can now replace our A. Our A is 2 times our R is negative 4 raised to the power of n minus 1. So this is our nth term. We cannot change this. I mean, we cannot simplify this further because we have negative 4 here as our base. So this is the formula that can be used to find any of the values here. You can find negative 128 by using this formula. Negative 128 is A sub 4. This is A sub 1. This is A sub 2, A sub 3, and A sub 4. So it means that 2 times negative 4 raised to the power of 4 minus 1, because that is our A sub 4, will be equal to negative 128. You can check this in the calculator. Okay? So the nth term is also called as the general term. It is the formula that can be used to find any of the terms in our geometric sequence here. Okay, number 6, you're going to contract AB and BC. AB is an edge. It means from A to B, this. And BC is from here to here. So it means that we're going to delete 2 edges. Contracting means deleting. Okay, we remove the edges and short circuit the points involved. This is the exact meaning of contracting in graph theory. It means we will remove the edges involved if we have 2 or more, sometimes only one, okay, only one edge. And we are going to short circuit. Short circuit means we're going to combine the points or the vertices involved. Here, if we're going to remove our A, B, and BC, three points will be affected, okay? So I'm going to put the answer here. So here, I'm going to put my W, okay? Our W here contains 3 points, A, B, and C. Because these are the points involved when we delete A, B, and BC. So they are together now. Okay, we have our D here, and here is our E. So these are the only points remaining. Originally, we have 1, 2, 3, 4, 5. There are 5 points. Now it's going to be only 3 points because A, B, and C are combined or merged. Okay, so let's now have our connections. Okay, A to B deleted, B to C deleted. So A to D, this one, that is from here, because our A is here now. Okay, and we have also D to C. So it's going to be a multiple edge. Okay, this is from D to C. We can label also this if you want, okay, to avoid confusion actually. And the last is this A to E. Okay, A to E, our A is here and our E is there. It's gonna be like that. This is our answer. Okay, so that is how to contract an edge or edges. We have to delete the edges or an edge and short circuit the points involved. And here the points involved are 3. Okay, so let's now proceed to number 7. Here you're going to identify the premise in the following argument. People should not use drugs as they possess chemicals which are detrimental to health. So premise, the most common indicators are since, because, as, for. Okay, so these are very, very common. So premise, these are the reasons. Reason or reasons. So we say evidence or evidences. It answers the question why. Okay, so the premise answers the question why. So here, why is it that people should not use drugs? So this is the reason. And our indicator there is as. As is equal to because, for, or since. Okay, so the premise here is letter C, as they possess chemicals which are detrimental to health. Detrimental means it has negative effects. It means harmful. Okay, so the remaining will be our conclusion. Here our conclusion then is people should not use drugs. So conclusion is our claim. Claim or claims, if you have 2 or more. It is the point we're trying to make. The point we're trying to make. Because I might reverse the question. I might be asking for the conclusion instead of the premise. Okay, so I hope that this is very clear. Okay, let's have other examples here. Here the answer is letter C. Now let's have another argument here. John will probably receive the next promotion since he has been here the longest. So here our keyword, our indicator is since. So the premise, this is without S, there's only one. He has been here the longest, or since he has been here the longest. And our conclusion is John will probably receive the next promotion. Why? This is the reason. Okay, this is the reason why John is going to receive the next promotion, because he has been in the company the longest. But this is not always true at all instances, right? So here I did not study well, so I did not get A+. Here the keyword is so. So therefore, okay, hence, what else? Consequently, these are the keywords. Thus, so our conclusion here is I did not get A+. What is the reason? I did not study well. Okay, so I guess this one is very, very clear now. Let's go to number 8. Which of the following deductive arguments is an invalid argument? So there are two valid forms. The first one is AB, CA, CB, and A should be general. Okay. Later, I'm going to show the second one. Okay, so before the verb is our A. That's before the verb. So this is our A. So this is our verb. So this is our B, predicate. B actually is the predicate. And A contains usually our subject. And an eagle is not mentioned in the first sentence. This will be our C. Bird is A. And therefore, an eagle. Eagle is C. And flies is B. Okay, fly, flies. Okay, simple present. So this is the base form of flies. So this is valid. Okay, the first one is general, all birds or every bird. Okay, and it follows A, B, C, A, C, B. Okay, this one is general, all counting numbers. That's our A. Integers, that's our B. Every integer, B. Real number, we don't have. So this will be C. It's not mentioned in the first sentence. And here, all counting numbers. This is A. And real numbers, C. Again. So it is A, B, B, C, A, C. This is the second form. And both of these should be general. Okay? Why? Because if the premises are true, the conclusion cannot be false. That's the meaning of a valid argument. Here, all birds fly if this is true. An eagle is a bird, therefore an eagle flies. So assuming that the premises are true, then the conclusion cannot be false. Okay? The second one is also valid. It is using the second valid form. This is the first, and this is the second. A, B, B, C, A, C, but A and B should be general. Like here we have all. When I say general, all elements are included, all counting numbers. Here, every integer. When I say every integer, all integers. Here, all monkeys, that's our A. Mammals, B. Here, a baboon, that is our C. Monkey is A. So it follows A, B, C, A. First one is general, all. And here, a baboon is C. Mammal is B. So again, this is valid. So the answer here will be D, because we're looking for an invalid argument. Okay, the rest are all valid. So the last one will be invalid. All robots, this will be our A. Actors, B. Alexa is C. Actor is B. So C does not follow A, B, C, A, C, B. It should be C, A. So Alexa, C. Robot here is B. So this is invalid. Now, sometimes the invalid argument looks like valid, especially if the given sentences are true in reality. But we are not looking at the truth and the falsity when we look at the validity. We look at the whole construction, the whole form. Okay, because if it follows the valid form, it is automatic. If the premises are true, the conclusion cannot be false. Okay? Let's go to number 9. Which of the following is an inductive argument? Okay. When we have deductive, usually it follows, this format, like we have the first sentence general, and then a specific, and then a specific conclusion. Usually we have three sentences. That is deductive. First one is deductive. All human beings talk. Ali is a human being, is like an example of this. And then we conclude that Ali also talks. This one is also deductive. First sentence, second sentence, and the third sentence, the conclusion. So deductive is always like this. We will start with the first two premises and then our conclusion. Same here, we have our first sentence, then Sindura is a mango, and Sindura is a fruit. So again, we have deductive. Okay, so deductive is always like that. We have three sentences. The first two sentences are the premises, and the last is the conclusion. So we will have premise one, premise two. Here, premise one, premise two, premise one, premise two, and conclusion. So this is the inductive. So deductive is from general to specific. Here we have all human beings. It is from general to specific. Then here we have Ali talks, specific. Okay, here Sindura is a fruit, again specific. Here 5.6 is a real number. Here we're going to start with specific and then general. So this is our general conclusion. So the keywords are observe or observation, experiment, survey, the survey, interview. All of these are the keywords when we have inductive argument. Our basis of our conclusion is our observation, sometimes gathered facts. Sometimes we have a sample, and based on the sample, we conclude. So most of the things, most of the arguments that we have in reality are inductive argument. Scientists, doctors, researchers use inductive argument most of the time. Okay, because usually we look at the sample and then we conclude about the population. So it is observed that all people in a particular city, although we mention all people here, but in one city only, this is a specific. Okay, in Nigeria, eat fish. Then therefore, all Nigerians eat fish. So our basis is this: all people in one city. A particular city means one particular city. So that is a specific. Although we have all people, but it's one city. And our conclusion says all Nigerians eat fish. Maybe the number of people in this city is, let's say, for example, 15 million. Okay, because Nigeria is so big. And the total population of Nigeria is more than 200 million. So just imagine, out of 15 million, we conclude that all 200 million eat fish. So our conclusion is uncertain. We are not sure whether it is going to be true or false. So we just say strong or weak. This can be considered as moderate because I believe that not all people in Nigeria eat fish, okay? In India, for example, we cannot say that all Indians eat fish or Sri Lankans because some people are vegetarians, yes? So they don't eat fish at all. Okay, so it is always uncertain when we use inductive argument because our basis is our observation, our sample, our experiment, or survey. Okay, so that's how to identify whether it is deductive, or inductive. So also you'll be asked to define these terms. It could be given in multiple choice, or you might be asked to define these terms during your test. For example, what a logic is the study of correct and incorrect reasoning. And here we have a sequence. These are the keywords. So it is an order of things. It means okay, it has positions, every elements or every terms. Okay, of course, we discussed this already in our classes. Arithmetic sequence, we go to the next by adding or subtracting. Geometric, we go to the next by either multiplying or dividing. Okay. Of course, graph theory, branch of mathematics concerned with networks of points connected by lines. So in short, actually, graph theory is the study of networks. Okay. And graph, it consists of two things, set of vertices and set of edges. Okay, that's it. Here, you're going to convert the following. The first one is an octal number. You're going to convert to a binary number. So we have 11A, 452 base 8 going to binary. So whenever you see 8 and 2 or 2 and 8, you're going to use 421 because 4 plus 2 plus 1 equals 7. Actually, which is the highest digit in the octal number system. So we stop at 4. We don't include 8. So the first is 4 equals 421. So we need the first digit only. Okay? We don't need 2 and 1. For 5, we need 4 and 1. So it is on and on. We don't need 2. So it is off. And 2 equals 421. This is off, 0, on, off. Okay, because we need only 2. So the answer is 100, 101, 010 base 2. Right, so letter B, we have D19 base 16 going to binary. Binary is 2 base 2. Okay, so you have to memorize this. From 10 to 15, you have to convert to the corresponding letters. We have from A until F. Okay, so it means that our D is 13. You can see here. So D equals 13, and we're going to use 8421 instead of 421 because we have here base 16. 8 plus 4 plus 2 plus 1 equals 15, or F, the highest in hexadecimal number system. So 13, we need 8, 4, and 1. So 2 is off, and 1, we need only 0001. Okay, only 1. And 9 equals, okay, of course, you know, it's 8 and 1. 8 plus 1 is 9. Okay, so our answer is 1101. That's for D13, and 001. That's for 1. 1001. That's for our 9. So don't forget the base here, base 2, because it is binary. All right. So let's proceed to letter C, 671 base 8 to decimal. So we have 671 base 8 going to base 10. That's the meaning of decimal. So please remember that for octal to decimal, we're going to use d times 8 raised to the power of n. Okay, if we have binary to decimal, you're going to have d times 2 to the n. Hexadecimal, we're going to use d times 16 raised to the power of n. So example of that is d1CE, base 16 going to base 10. So here you're going to use 16. So here we have 6 times, we label this, so this is 8 raised to the power of 2. So always start from 0 going to the left. 1, 2, 3, continue, okay? Here is only until 2 because you have only 3 digits. Plus 7 times 8 raised to the power of 1 because we have 1 here. Plus 1 times 8 raised to the power of 0. So this is 8, 8, and 8 because of 8 here. If it was 16 like this, you will be using 16 as your base. If it was 2, you're going to use 2 because it's binary, yeah? So here the answer is 441. Okay, in decimal, you don't need to write base 10, or you can write base 10 here as well. Okay, so we'll continue with the second set in the next video, from 12 to 19 or 20. Right, so thank you so much for watching. Until the next video, bye-bye.